So, we are still in section 5.4 talking about dividing polynomials, and you would think after yesterday, I mean, we learned how to long divide. Wouldn't that be it for polynomials, using that long division? And today is one of those lessons where when we get done, people always say, Cedarholm, why didn't you show us this before today? And it's really cool. I call this math magic. I really do. And it is to divide polynomials using synthetic division. But know this, okay? We had to learn long division. Synthetic division doesn't work for every division problem. It only works for division problems where they have us divide by something. Oh, there's that blue giving me trouble again. Come on, blue, behave. That's the only time we can use synthetic division. If they give us a divisor that's just x minus something. There's no number in front of the x. There's nothing crazy about it. It's just, hey, x minus something. And we've come to know those as just, really easy binomial factors. I mean, on the last test, we were using those to write our polynomials. So synthetic is not something that I could have taught you to replace yesterday's, because yesterday's they gave us things like this that we had to divide by. And notice there's a 3 in front of the x. Well, you can't do synthetic with that one. You can't. There's no way to do it. So what we have to do is learn both methods, because somebody along the way said, this long division, it just takes too long. I don't know why they said that, but yesterday we found out these are long, not necessarily complicated, just kind of long problems. And somebody said, can we come up with a way that the math would be easier behind this? Because really, we just needed the x's to match the powers. It was the numbers that were truly giving us our answer when we did those. And so we've got to learn about synthetic, and it's not going to be a gotta learn. You're going to love this. Like I said, I refer to it as math magic. So, synthetic division. Anything that's synthetic is man-made. It's not like real stuff. Like when you get clothes that says 100% cotton, that kind of thing. It's synthetic, which means it's a fabric that man-made. It wasn't a naturally occurring anything. It's the same thing here. Somebody noticed a pattern and said, I don't want to do long division all the time if I don't have to. So synthetic division simplifies the long division process for dividing by a linear expression, but here it is. Has to be in the form x minus a. So to use synthetic division, you're going to write the coefficients. Those are just the numbers, making sure that you get all the zeros. And we're going to write those down as a polynomial in standard form, just like we did yesterday. But we're going to leave all the variables out. So that's what omit means leave them out. Don't put any of those variables down or the exponents that go with them. For the divisor, reverse the sign. Now, what they're saying is this. It came to us like this. We only want to divide by a. Remember, we're going to ignore the x's and the powers of the x's. So what we're going to do is find a. And that's what we're going to divide by instead. So this allows you to add instead of subtracting, because we won't have x minus a. We'll just have a throughout the process. Now, most people, when you're in elementary school, the first math they start you out with is addition. And your elementary teacher usually makes it fun. It's like they bring M&Ms around and say, okay, you had 2 M&Ms, and I'm going to give you 3 more. Now, how many M&Ms do you have? And 1, 2, 3, 4, 5. Hey, it's 5. Now you can eat them, So they make addition fun. And then you're not so keen on subtraction because it uses a different part of the brain and it doesn't go as fast as addition did. Same thing with multiplication. Multiplication is something we pick up on. If our parents help us with flashcards and stuff, it's like, got this. Right away you can tell people what those multiplication tables are. But when they do division, It takes a little more thinking. It's a different part of the brain. So most people enjoy adding and multiplying. That's what this process uses. That's it. Adding and multiplying to get our answer. So it's a lot of fun. We're going to use synthetic division this first couple of times actually. I'm going to go pretty slow. And that's because the process is easy, but you have to see how it works. So we're going to use synthetic division to divide x cubed minus 14x squared plus 51x minus 54 by x plus 2. And what is the quotient and the remainder? So here's what we do first. We see that that's in that x minus a format. But I think, oh, well, anything with x, you always have to do the opposite like we were doing before. So I'm going to have to use a negative 2, which is right, because x minus a negative 2 would be x plus 2. So I'm going to be dividing by negative 2. However, this is not normal division. Remember how our normal division symbol looks? For synthetic, we kind of turn that upside down and almost make it look like half of a rectangle. Okay, my line's not straight. Like so. And then here's what they said. They said, take all the variables out after you make sure that it's in standard form and there's nothing missing. 3, 2, 1, 0, they're all there. So we're just going to take the numbers, which would mean that's a 1 x cubed. So we need a 1, negative 14, 51, and negative 54. Now I'm going to explain the process, and then I'm going to take you through it. The first thing I want you to do is to pretend that this is a box. So it's inside a box. Josh, you got to put that away and pay attention, please. So what we're going to do is this. When we're in the box, we add. When we're outside the box, so out of the box, we multiply by a. And I'll put those little quotation marks around our a. Because remember, the first thing we did was we picked out a. So this is a, that number out in front. Now, how are we going to do that? Because we need to know an order here. And the order is you have to oscillate outside the box, then inside the box. Outside the box, inside the box. So oscillate outside, inside, outside, inside, and I'm just going to put etc. until you're done. Okay, Cedarholm. So if we have to oscillate back and forth between outside, inside, how do we start? I mean, there's all kinds of numbers up there. Well, remember, that first number is called the leading coefficient. This leading coefficient is going to start us off. Right now it's inside the box. We're going to put it outside the box. That's how we start. When you're outside the box, you multiply by a. 1 times negative 2 is negative 2. Now I have to go inside the box. Now I add because I'm inside the box. And I'm back outside the box. And when you're outside the box, you have to multiply by a. So negative 16 times negative 2 is 32, and now I have to go inside the box. I'm inside the box, I have to add. Now I'm outside the box. When you're outside the box, you got to multiply. Which this one, maybe you could do it in your head and get the negative 166 right away anyway. But I'm going to write it here so everybody can see it. And then when you're inside the box, you add. So we're going to add those two together. And it's nice that they're all lined up because then you can do your addition like normal. So 4 and 6, 10. Carry the 1. There's your 2. And we've got negative 220. Okay. Cedar Home, that doesn't look anything like our answers from yesterday. Well, it's because we're not done yet. This is the answer minus the variables. So here's what we do every single time. We start in that far right corner, and we say, this is the remainder. The next one will be x to the 0, which is the constant. So that's a C. The next one will be x to the first. And the next one will be x to the second. And notice how it's backwards. You know, we start over here on the right, remainder constant x squared. That's our answer. So our answer is x squared minus 16x. Oh, I wrote that too high. Again, let me know if people can't see stuff. X squared minus 16x plus 83 minus 220 over, our divisor was x plus 2. Magic wand. Ta-da! What do we say? Abracadabra! There. So by just doing adding and multiplication, we did what we had to do long division for yesterday, which is pretty cool. I mean, that's amazing that we can just add and multiply. So that's our first one. Like I said, took that kind of slow. Going to take this next one kind of slow too. Some people get fast right away. The key here is, if anything's missing, you have to have the 0 in there. Even if it's that last number that's sitting all by itself, the constant, you got to have a 0. So we're going to use synthetic division to divide x cubed minus 5x plus 56 by x minus 7. Well, there's my x minus a. So help me out. What should we use for a? Careful. 7, right. Because that minus, remember, x always does the opposite of what we think it should do. So if it looks like a negative 7, it's actually a 7. And while I was saying what this polynomial was in my head, I'm thinking, well, this one's missing something. It's x cubed, and then it's all the way down to x to the first. I'm going to have to put a 0x squared in there. So 3, 2, 1, 0, all the powers are now taken care of. So now I can write down those coefficients. Coefficients, fancy language for the numbers in front of all the variables there. All right, so now I have to remember where to start, which isn't hard when you remember the name leading coefficient. So I have to bring down that 1. Right down there. I'm outside the box. What do we do when we're outside the box? Multiply. 1 times 7 is 7, and we go inside the box. What do we do inside the box? We add. 0 plus 7 is 7. We're back outside the box. So again, we're going to multiply by a. We're back inside the box. Now we add. We're outside the box. We multiply by a. Oh, look at this one. That's special. Put a box around that. What does a 0 in that last position mean? Good. There's no remainder. Because remember, we start remainder constant x squared. So our answer this time won't have a remainder. It'll be x squared plus 7x minus 8. And there it is. So, yeah, usually after doing the long division, people are like, oh, I like this one so much better. Couldn't we do this for all of them? Remember, we can't do it for all of them. You know, it has to be in that x minus a format in order for us to be able to do this. In fact, we can even use this for word problems. And we have one here. Using synthetic division to solve a problem. The polynomial x cubed plus 7x squared minus 38x minus 240 expresses the volume in cubic inches of the shadow box shown. Now, hopefully that takes you over here where you see, oh, look, they gave me something. There's an x plus 5 over there. Now, what do they want? What are the dimensions of the box? Hint, the length is greater than the height or the depth. Okay, so volume of a box is length times width times height. Well, they gave me one. You know, I know the volume is supposed to be this x cubed plus 7x squared business. And on the other side, well, they gave me x plus 5 on the picture. And that one, pretty obviously, is the width. So we're still looking for the length and the height. Okay. Well, if we were just thinking about algebra, we'd say, well, I have to divide both sides by x plus 5 so I can figure out what I have for the length and the height. And that's exactly what we need to do. So then the question becomes, can I use synthetic? Because I think we should all agree that synthetic is easier than long division, right? Takes less time? Yeah, and we can because it's got the x plus 5. So we'll make our upside down box. And what number should go out in front for A? Good, -5, yes. Now let's make sure everything's there. And even if something's missing, we got to put a 0 down. 3, 2, 1, 0. Hey, they're all there. So like I said, even if that 240 was not there at the back, we have to put a 0. That's the only way synthetic works. All right, bringing down the leading coefficient. What do I do with that? Multiply and put it in the box. In the box we add. And now people are getting to the point, I look out and I can see, shut up, Cedar Home. We know how to do this now. So go ahead, do the rest of the math. Should we have known that that was going to be a 0 in that last spot? It has to be, because they said x plus 5 is a part of this. It was a part of that box. So it had to work out. Well, now let's see what we have left so we can answer their question about length and height here. Remainder constant x squared. So x squared plus 2x minus 48. But that's 2 dimensions because that's the length and the height multiplied together. So what we want to do is factor to break it apart. There's no common monomial factor that we can pull out of that. It's not anything special. -48 is not a perfect square. We need the 2 numbers that would multiply to -48 and add to 2. What are they? Google Meet, you guys can help out too. The 2 numbers that multiply to -4. Thank you. So those are the other 2 dimensions. Now they gave us a little hint up there. the length is greater than the height. Well, then it has to be the one that they're adding to. So this has to be the length, and that has to be the height. Because with this one, we're going to add and make it bigger. But with this one, we're going to subtract. So those are the other dimensions. And yeah, it was in inches, but this is what was really important here, is that we could break it apart. So with that x plus 5 that they gave us for the width, we're able to find the length and the height. And then part B says, well, now that you're so smart and you figured this out, let's give you an x value and see if you can find the other values. If the width is 15, oh, so this, x plus 5, is 15. Well, look at that. They're practically handing us what x is. We just have to solve that. So what do we do to both sides? Subtract 5. If we know x is 10, then we can plug the 10 back into x plus 8 and x minus 6. So these we can now say this is inches, because they gave us a value for x. So we could use that in each one of these little binomials that we have here and figure out what those dimensions would be. Now, of course, for the got it, they're going to change it a little bit. So we have a new polynomial. It's x cubed plus 6x squared plus 11x plus 6. That's our new volume. And we've got...
Can you move it a little bit so
Oh,
I can correspond?
thank you. Went too far up. If the polynomial x cubed plus 6x squared plus 11x plus 6 expresses the volume in cubic inches of the box, and here they go, here's the huge starter, x plus 1 is the width. What are the dimensions of the box? So again, they're giving us one, and we find the others. All right, help me out a little more this time. What number should I put in front? Good, -1, the opposite of what we see with the x. Now, I want you to take a peek. Let me know if we have to put zeros in for anything. Everything's there? Okay, so what numbers are you writing down?
1, 6, 11, 6.
Excellent. Before we start, what is our remainder going to be? 0. If it's not 0, we messed up. So that's another, hey, this isn't the hardest process in the world, but I'll know I messed up if I don't get a 0 for my remainder. Outside the box, multiply. Inside the box, add. Outside the box, multiply. Inside the box, add. Outside the box, multiply. Well, look at that. Came out to 0. So far we know we're batting 1,000. It's working great. But the important part is what's left, that we can read this off. So again, you start in the far right, remainder, constant, x squared, x to the third. Keep going as far as you need to. And this we can factor. No greatest common monomial factor. Nothing special about it. But we need the two numbers that make this work. So think about it for a minute. Good. 2 and 3. Excellent. There they are. There's the other two dimensions. Now we could put inches by them because it did say it's x plus 1 inches. But this got it is not like the last one where it said, hey, we're going to give you a value and you can use that to find the other ones. This is just a, hey, we see how this works now. You know, if we use synthetic, this is really slick and it goes really fast. In fact, it turns out synthetic can be used for something else that we used to have to use a calculator for, but we can turn it into the, hey, all I have to know how to do is add and multiply. And that is the remainder theorem. So this is a really big theorem in algebra. The remainder theorem provides a quick way to find the remainder of a polynomial long division problem. Well, of course it does. We just found out that last number that we see there is always the remainder. So, the remainder theorem says if you divide a polynomial that has at least an x to the first in it by that x minus a factor, then the remainder is that p of a, that last piece that we have there. Now, this one, they make something very easy look hard, but let me show you what they're doing. When we divide a polynomial, we get the divisor times the quotient plus the remainder when we want to check it, when we put it back. And the divisor for synthetic is always going to be x minus a. So this is asking, what's going to happen if we put a in there? I mean, if it says x minus 2 and we put a 2 in here, or x minus 3 and we put a 3 in there, well, then it's going to be 0. So that means all of this portion will be 0, and we'll be left with the remainder. Now, here's what this is useful for. And yeah, I've got the little monkey here saying, duh, but they made it sound difficult. You know, it was supposed to be irony that I did there, because they made it sound difficult. But all it's saying is, if you put a number into this synthetically, the last number is your answer. So, notice this one does not say x minus a anywhere in it. Given that p of x equals x to the fifth minus 2x to the third minus x squared plus 2, what is p of 3? Doesn't say x minus a. That means I don't have to do anything to that 3. I can just put the 3 out in front. Now, in the old days, we would have grabbed a calculator for this, because we'd say, all right, I have to figure out if you put a 3 into this, what you get. Now, look what we'd have to do in our heads if we did that. 3 to the fifth. 3 times 3 times 3 times 3 times 3 minus 2 times 3 cubed, 3 times 3 times 3 minus 3 times 3 plus 2. People wouldn't do that in their head. Most people aren't going to get past 3 to the fifth in their noggin. So let's try this synthetically, because the last number is supposed to be our answer. But this one we have to be careful with, right? Do you see what's going on? What would you warn somebody about with this one? You need some zeros. Yeah, we have x to the fifth, but then we don't have an x to the fourth, so we need a 0 for that. We have x to the third is negative 2. We have x squared is negative 1, but uh-oh, they missed an x. So what we're trying to do is just use adding and multiplying to figure out if you put a 3 into this, what would you get? Well, let's do it. Bring down your leading coefficient. Do your multiply, add, multiply, add, multiply, add. Did you have to grab a calculator for any of that? No. Where's our remainder? What is it? That's our answer. The remainder theorem said, here's your answer right here. That'll give us the exact same answer as if we put this 3 right here back in for all of these x's and grabbed a calculator without ever touching a calculator. That is so cool. That's why this is math magic. Somebody saw it, they saw the patterns, and they said, Oh my goodness, we've been doing this the hard way forever. Let's use synthetic. Now, we just received a notice a week and a half ago about the MCAs in April. Last year, the juniors didn't have to take the MCAs because of everything that was happening. Right now, we have no idea. So I want to show you this. I reminded you about this earlier this year. The gridded response thing that might show up on the MCAs. Remember, you can put your answer all the way to the left. You can put your answer all the way to the right. But if you put your answer in the middle, they count it wrong. So our 182 could go here, or it could go here, but it can't go anywhere else. Otherwise, it gets counted wrong even though you did the math right. Well, let's do one more of these. These are like little math puzzles. They're fun. Given that p of x equals x to the fifth minus 3x to the fourth minus 28x cubed plus 5x plus 20, what is p of negative 4? Again, no sign changing. That's not x minus 4. It's just p of negative 4. What's the warning about this one? We do, yeah. The x squared term, we're going to need a 0. Again, if that 20 were missing, we would even need a 0 there. You have to go all the way from the highest power down to the constant. Looks like you guys are already doing it. Do that. Keep going. Go ahead and do the problem. Let's see if we all get the same thing. So what's our answer? 0. Again, that is so cool because we would definitely use a calculator. We'd have to use parentheses to do negative 4 to the fifth minus 3 times negative 4 to the fourth minus 28 times negative 4 to the third plus 5 times negative 4 plus 20. It takes longer to punch it in than it does to just do the math with that man-made synthetic division. Super cool. That's what we had to learn today. That was our objective. And it looks like everybody in here is just cruising on it. So let's have some more fun. And do those. So this is section 5.4, day 2, page 308. 21 to 39, the odds. 41 and 48 to 52. Emily, can you see that from where you are, or should I move it up? You can see it? Okay. How about you, Avon? You okay? See it back there? All right, good. Because this is kind of the non-glare spot for the Google Meet folks. All right, math magic.